Today we're going to be building off and finishing up this learning target, which is I can find the integral using U substitution. We're going to be taking a look at examples that have trig functions in them. This right here, we can rewrite with parentheses 5x. Basically, if I rewrite this function in this format, I can easily see that my inner function here is 5x. That's why I colored my inner function blue. The dx is always going to be in red because that is the process of U substitution. Alright, my first step, make the U equal to the inner function. Next step is take the derivative of both sides with respect to x. Once you do that, the derivative of 5x is just 5. On the left here, you just have du dx. Next up, in order to solve for dx, because that's our next thing, we've got to solve for dx. You're going to multiply both sides by dx. Over here on the left side, these cancel. You're going to be left over with du is equal to 5 times dx. Great. So now we have our du. But we got to solve for dx, so my last thing that I have to do here is divide by 5. That's why I color coded this in red, because we're going to substitute that into here in a second. But before I do that, I'm going to be substituting the blue function in for u. Now I'm going to substitute that red right here that I found over here. Next up, this divided by 5, I'm going to pull it out in front, so that's 1/5. Now I am able to take the integral. The integral of cosine is just going to be sine, because I know that the derivative of sine is just positive cosine, and then the 1/2 is going to stay in front. And by the way, you should have your red resource sheet out so you can remind yourself of the derivatives of trig functions. Great. So now that I found my antiderivative, my last step is to go ahead and plug in my u. And we are done with example 5. Feel free to pause this video if you need to go over these steps again. Let's take a look at example 6. Example 6 is very similar to the last example, except the parentheses right here are already written for us. That makes it easier to determine what the inner function is. I color coded the inner function as blue. The dx will always be as red. Again, I make my u. I take the derivative of both sides with respect to x. The derivative on the right side is just going to give us 4. In order to solve for dx, I'm going to multiply dx both sides. Cancel, cancel. You have du is equal to 4 dx. Again, the goal is to solve for dx over here so that we can substitute that in. So then in order to solve for dx, I'm going to divide both sides by 4. There we go. There we go. I have my red function. Next up, so now that I have my blue, which is u, and I have my dx, which is over here, I'm going to go ahead and substitute. First, I substituted the u. Then I'm going to substitute the dx, which is du over 4. Alright, this divided by 4, I'm going to pull that out in front so that it turns into 1/4. Now basically what I'm doing is finding the antiderivative of sine u, and then I'm just going to keep this 1/4 in front because it's a constant, it's a number. So the antiderivative of sine u, so I know that the derivative of cosine is negative sine, so the antiderivative of sine of u is going to be negative cosine because this is positive. And then we're going to have the 1/4 in front. So as you can see, I made this negative because the derivative of negative cosine u is going to give me the positive sine u. Alright, now what I'm going to do next is this negative, I don't like it written this way. I'm going to move it in front of the 1/4. My last step is this blue u right here. I'm going to substitute my original function. There we go, we are done. This next problem is a little interesting because it might be a little harder to tell what is the inner function since there are no parentheses. But if we take a look over here to the 4th power, we remember in trig functions, the 4th power is written usually before the x or the theta. This right here is actually equivalent to this, parentheses with the 4 on the outside. So now I am better able to identify what my inner function is. So I color coded that as blue. So this is actually sine is my inner function. Well, actually sine, it's just sine, not the 4. The 4 should not be blue, by the way. just sine is going to be my inner function. The cosine is just cosine, and my dx I'm going to substitute in a bit. Again, this looks like this. Okay, so just clarification, this 4 should be black because my only inner function is just the sine. Just a clarification there. The outer function here to the fourth. That's we're going to take care of later. All right, so my inner function is sine x. I'm going to take the derivative of both sides. The derivative of sine is cosine. I'm going to multiply both sides by dx as usual. Then to solve for dx, I'm going to divide both sides by my cosine. So I have my dx solved for, I have my u, and I'm going to go back here and make my substitutions. Because sine was u, this right here is going to become u to the fourth power, then cosine dx. So as you can see, my inner function was just sine x. Alright, next what I'm going to do is substitute my dx, which is this. Luckily, in this example, the cosine from here will cancel with the cosine from here. That's going to make our integration much easier. Alright, so the integral of u to the fourth is just going to be u to the fifth over 5. Because we're using x to the n plus 1 divided by n plus 1 rule. And we have our plus c. Now my last step is to go ahead and substitute my original u, which is just going to be sine. And then I'm going to rewrite this in this format because these two are equivalent, their meaning. So that is number 7. Again, feel free to pause if you need to. Here's the last problem. This last problem is a little tricky because I have squared over the tangent and I also have the secant of squared, so I don't know which to choose for my inner function, so I have to make a choice. Alright, so here's how I'm going to make my choice. I would look at my red resource sheet and I would identify the derivative of what function. So I know that the derivative of secant x is going to give me secant x tangent x. That could kind of work if we did some manipulation. But I do see that the derivative of tangent x is secant squared x. So I feel like, okay, if I know the derivative of tangent x is secant squared x, I'm going to make my inner function the tangent. And see how I rewrote it with parentheses and squared on the outside? I made a choice to make this my inner function because I know that the derivative of tangent is going to give me secant squared x. Therefore, later on, I know that will cancel. So I'm making predictions here, and I made a choice that's going to make the math easier. Alright, so my inner function is tangent x, my u equals tangent x. I take the derivative of both sides. Using my red resource sheet, the derivative of tangent x is just secant squared x. Multiply both sides by dx to get this, and then divide both sides by secant squared x to solve for dx. Good, we have my u, we have my dx. Let's go ahead and make our substitutions. First, I substituted my u. Now in this next step, you're going to see I'm going to substitute for dx. Good. Now as you can see, now this works out very nicely because now I could cancel out this secant squared x altogether. Now I have a very nice antiderivative to find. So now the antiderivative of u squared is just going to be u cubed divided by 3, all plus c. Then I just got to substitute in my u, which is tangent. So that's just tangent x to the third divided by 3 plus c, which means the same thing as this. The cool thing is if you take the derivative of this, you'll see that you'll get this by chain rule. Alright, those are your new examples. Please make sure you try to do the other problems on your own and ask me any clarifying questions in class.